Students, in the previous slides, previous video, we have studied about the layered approach of software engineering, focusing on the stages that it is involved, like quality, process, methods, and tool. And we have studied about what is process and what is the importance of process in this layered approach. Now, coming to a specific type of process, which is generally followed in software industry for developing a software, is known as SDLC. SDLC stands for Software Development Lifecycle, or when your focus is only on the softwares. Okay, but when this software is a part of a larger system, like if I have a, a car, an automated car, or self-driving car, there is a mechanical system, there is an electronics based system, there is a software system that actually governs the complete car, right? Driving system. Now, the software is not only the part that is driving it, but everything else is helping, and software is coordinating every part of the car. So now that cannot be software development life cycle, it will be a system development life cycle. Now, SDLC is a generic process framework that establishes the foundation for a complete software process by identifying a small number of framework activities that are applicable to all software processes or projects and regardless of the size and complexity. That means this is a generic process framework. That means it is a generic, it's applied to all the projects that you apply, that you create. From smaller to medium to large size projects, you can apply these stages to any of the projects. It will also have certain activities that you need to do. This is small, but yes, they are activities that are complete in nature and they help to develop a economical, reliable software. So let us study what are the stages. The first stage is called communication. This is a framework activity involves heavy communication and collaboration with the customer and consists of requirement gathering and other related activities. We will see what are requirement gathering and how we do requirement gathering in our next lectures or coming lectures. But as of now, understand that any if you want to start a process, work, then the first thing is communication. Communication here refers to uh, the to and fro of information between the client and the team or developing team. Okay, they have to discuss a lot between what they want and how they want, and you also need to understand how you are going to create that software product. Okay, so you have to spend lot of activity, lot of time discussing about the project. So discussion is an important part of any successful project. Okay, the second is called planning. Once you are done with all the requirements, you know what are the requirements, then in that case, this stage comes for planning. This activity actually, now when you know all the requirements, now you need to plan what are the technical tasks to be conducted, what all things you need to do for completing this project. You also know you should also try to mitigate, understand what are the risks involved in this process. Okay, technical risk, human risk, a financial risk. Okay, all these three risks you should identify, and for all these three type of risks you need should have a mitigation plan, a plan which is a plan B, suppose, right? If this happens, what will be the next stage, how we are going to overcome this risk. This is how it is known by mitigation. The third is resources that are required, maybe a human resource or a system resource. You require certain servers, certain databases, certain people, certain platforms, some licenses. You should know the resources that are required in advance. So before the coding actually begins, you should have all these things at your place so that you are not stuck at the time you are developing something. Then you should also know what are the deliverables. That means what all things you will create once you go to the coding or the modeling or the construction phase. That means you should understand what all things you will create in the process of software development. And finally, you should create based on this, all this work, all this previous works, you will create a work schedule. That means you will create work schedule so that you know that this thing has to be done at this part of the project time, other thing has to do at another project time. So you will have a complete a process chart or work schedule chart. So saying that you will manage that if we want to know that 30% of my project should be completed in 3 months, then you should track the project. If you are over 30%, then it's good. But if you're under 30%, you need to work more now. Okay, so this is what is called scheduling. So planning actually we have scheduling. The third activity is called modeling. Modeling here is referred to designing. Okay, to better understand the requirement. Sometimes you write a text and text is not clear. Okay, that doesn't convey the message. I am not able to understand the message from your text. Okay, sometimes it happens as a teacher when I evaluate a copy. Okay, when I check a copy, and I find something confusing, I give less marks. The student when he sees his copy, he said, "Okay, sir, I don't mean this by this statement. I mean something else." So I say that at the time of checking the copy, you are not present. Okay, I am checking the copy, I am reading the text, and I'm assessing it based on the text that you written. I don't know what you mean, what were your expressions, what is in your mind. I cannot read it. Okay, so that's the problem of text. That means when you write something, might be possible that it is clear in totality, or it might be confusing, right? It will be clear because you are writing it, you thought in that way that I am writing the best, but when the person reads it, he gets more confused. So to remove the confusion, we will actually create diagrams. Okay, we will actually create certain more models. Now, when I read when I read a text and I see the diagrams, if the diagrams is correct, I can correlate these two things. Okay, I may understand. Okay, you want to say this, but because your drawing says is much clear, it says something else. So I will correlate these two things and get a better understanding of those requirements. So this is how actually helps in modeling. In modeling, we create designs, and the designs are in sync with the requirements. Then comes the construction. Construction activity is a combination of coding and testing in which the developer codes and tests the system. Now, testing may be unit testing or system testing or acceptance testing, depends. So, it actually has many things. We will see the testing parts when we come to topics of software testing. But this construction phase has two parts, coding and testing. And testing, the main objective is to find out the errors. Okay. Last point is called deployment. The software as a complete entity or a partial completed increments is delivered to the customer who evaluates the delivered products and provide feedback based on the evaluation. So the deployment is a phase of software development life cycle where you actually create once you have created all the code, you have packaged the code. Now you are going to deploy it on the client machine, either fully or in parts or increments. We will see in the other lectures that some process models like incremental model or RAD model, or you can say spiral model, prototyping models actually take care of increments. Okay, so they create increments, small patches of work, and they release it one by one. Okay, so they make the project complete. So now the customer will evaluate and provide his valuable feedback. Based on the feedback, you again go to communication phase, again start the communication, planning, modeling, construction, and deployment. This is the phase, the cycle, which goes on and goes on. Okay, so this was all about software and software development life cycle. So I hope we have covered most of the things in this. And the next, we are going to see the software process models like waterfall model, incremental process model, evolutionary process models, and component-based process models. Thank you.